Hi, my name is Dr. Steele, and today we are going to be talking about probability. This is part of a series, so feel free to check out the other videos. Today we are going to be talking about the addition rule of probability, another way of saying the types of probability questions where you have what's the probability of finding this or this. First, we'll look at mutually exclusive events, or also disjoint, same thing. We'll look at a Venn diagram, some formulas, and some examples. Then we'll look at non-mutually exclusive events, same thing, Venn diagram, formulas, and examples. Then I have a challenge for you, and then I have a PDF you can download that summarizes the video. Now here's a flow chart. It has mostly definitions and also formulas that you'll be using. Again, today we are only going to be focusing on the OR part. And yes, I will make sure you have this table. All right, so let's look at the definition. The addition rule of probability is used to find the chance of one of two events happening. It is done by adding the probability of each event. If both events can happen at the same time, the overlap is subtracted to avoid counting it twice. So our first formula for the probability of A or B is the probability of A plus B, and that is if two events can't happen at the same time, right? Then we're just going to add their chances together. And then we have probability of A or B equals the probability of A plus B minus the probability of A and B. And we'll get into a little bit more of why that minus happens, but you can just remember if the events happen together and their chances are added, but if we can have both of them happen at the same time, then we have to subtract that overlap, and that's why we have the minus probability of A and B with this formula. Okay, so first, like I said, we're going to look at disjoint or mutually exclusive. I'll be using both words. Again, they mean the exact same thing. Okay, so let's say we have the probability of A, and it's in this pretty yellow circle. And then we have the probability of B. Now, there is no overlap. These two events cannot happen at the same time. And so if we're trying to find the probability of one or the other happening, we're just going to add those two together. So if we have the probability of rolling a 3 or a 6, that's an example. Now, suppose you're about to draw a card from a deck containing the following cards: 3 reds, 2 blue, 4 green, and 1 yellow. What is the probability of drawing a green or a blue card? You can answer. Don't overthink it. There's a nice picture and everything. Yes, I'm waiting for your answer. Okay, so we have 6 because we have 4 green cards and 2 blue cards. That equals 6. So we have a total of 6 out of 10 cards, and we always want to simplify. And so if we divide 6 and 10 by 2, it's going to simplify to 3/5. Great. Now, that's looking at a picture, giving some information. You can do that. Now, let's just have the same thing, but now let's use a formula. For these, I go straight to the question. I'm looking for a keyword. So, what is the probability of drawing a green or a blue card? That or is telling me I'm going to use an or formula. And so the probability of A is going to be drawing a green card. And so we have 4 greens out of a total of 10 cards for 4/10. The probability of B is drawing a blue card, and we have 2 blue cards out of a total of 10 cards. And so the probability of A plus the probability of B equals 6/10. And as we just saw earlier, same thing as 3/5. All right, let's look at another example. All right, so now let's look at non-mutually exclusive. That means that 2 events can happen at the same time. Now, if we were to make a Venn diagram, we have here again is our probability of A, our probability of B. Now they can happen at the same time, so there is going to be an overlap. Now, an example of this is the probability of Black Panther being classified as a superhero film or as a blockbuster hit. They definitely can happen at the same time. All right, so let's do another example. We have 100 students are surveyed. Probability of A is 40 students regularly attend the gym. Probability of B is 50 students own a pet. And the probability of A and B is 10 students both regularly attend the gym and own a pet. And so that's where we have that overlap. So that's why we have that 10 in that pink section. Now, before we had a nice 40 because that represented the students that attend the gym, but we did not take into account that there's also 10 that also own a pet. And so if we wanted to represent this correctly, instead of having that 40, it's going to be 30. And then the same idea, again, probability of B is that 50 students own a pet, but we have to take into account that 10 of those, they also attend the gym regularly. And so now we're going to change that 50 to 40. So now this is going to be the information that's given. Now we have 100 students that are surveyed, and there's 20 students that aren't in any of these categories. And so if we were to draw this, you would have 20 that are on the outside of the two Venn diagrams. So let's find the probability that a student regularly attends the gym or owns a pet. All right, there's that nice or. So we are going to use our formula. Now you might say, well, this is different than the formula you just had on the other slide. Yes, and we did cover why, right? Because these are non-mutually exclusive, meaning they can happen at the same time, because we do have someone that attends the gym and owns a pet. And so that's why we have to subtract. That's why we have that additional minus probability of A and B at the end. Okay, so let's write this out. Probability of A is 40 students frequently go to the gym. So we're going to have 40 out of 100 students. Probability of B is that 50 students own a pet. And so that's going to be 50 out of 100 students. And then we're going to subtract the probability of A and B, which is the probability that students both regularly attend the gym and own a pet. And so that's going to be 10 out of 100. And that's going to equal to 80 out of 100, which again, we want to make sure that we simplify. And so our final answer would be 4/5. All right, now let's look at a comparison side by side of our two different formulas. Now, let's say we have numbers 1 through 6. So the first one, our event A is going to be getting an odd number. And so that's why in the circle you have 1, 3, and 5. And then event B is to get a 6. So that's why in that B circle you have a 6. And again, we have numbers 1 through 6. And so 2 and 4 are not included in any of those events. Now, if I said, what's the probability of getting an odd number or getting a 6, we can look and say, well, there's 3 in A, 1 in B, so that's going to give me a total of 4, right, out of 6. Now, if we use a formula, the probability of A is 3 out of 6. The probability of B is 1 out of 6. And that's going to give us 4 out of 6. What a surprise. Again, you want to make sure you simplify, and that's going to simplify to 2/3. Now, let's look at the other one. We have the event A is getting a number greater than 4. So in A, we have both 5 and 6. And then event B is getting an odd number. So we have 1, 3, and 5. So if I said, what's the probability of getting an odd number greater than 4? Of getting a number greater than 4 or an odd number, we can count 1, 2, 3, 4. There's 4 in the circle, so it's going to be, again, 4 out of 6. But if we use our formula, the probability of A, in A, we have 2 out of 6. Again, those are numbers greater than 4. Now note, I said greater than 4, not greater than or equal to 4. So keep an eye out on that. Probability of B is an odd number. And so we have 3 out of 6 that are odd. Now here's the subtraction part. Again, we have to subtract the overlap. So we're subtracting a number greater than 4 that is also odd. And so that's only 1, which is 5. So 1 out of 6. So that's going to give us 4/6, and that's going to simplify to 2/3. Not so bad, not so bad. All right, so the probability of A is 49/100, the probability of B is 5/10, and the probability of A and B is 46/100. Find A and B. And note the probability of A and B are disjoint, which means this is a formula I'm going to use because they tell me they are disjoint. And so 49/100 plus 5/10 equals 99/100. All right, now we have the same idea, but instead of them being disjoint, they are independent, which means I'm going to use this formula. We're going to do the same thing. We're going to add A plus B, subtract that overlap, and we are going to get 53/100. All right, now let's look at the ones everybody loves, the ones dealing with the cards. So, again, I'm going to go straight to the question. What is the probability of drawing a 5 or a jack? Looking for my keyword, which is or. All right, so that means I'm going to write out this formula. Now, you probably noticed that even if I write out this formula and there is no overlap, it's okay because I'm just not going to have anything to subtract. So if I was to be doing these type of questions, I would just always write out this formula. That way it keeps you from forgetting to subtract the overlap if there is an overlap. Okay, so the probability of A is drawing a 5. So if we look, we have 4 5s, and we have a total of 52 cards. And then the probability of B is a jack, and we have 4 jacks out of 52 cards. And then we want to subtract the probability of drawing a 5 and a jack. Well, that's not possible. So we have basically don't need that. And we're going to subtract 0. So the word for these, are these going to be disjoint or are they independent? They're disjoint. If you didn't know that by now, I'm going to need for you to stop, rewind, and watch it again, okay? And so our final answer is going to be 2/13. Again, straight to the question. There is only the question, but typically you have some long scenario, and you need to just go to the question. What is the probability of drawing a red or a king from a deck of cards? All right, there's that pretty or question, so I'm going to write out my or formula. The probability of A is drawing a red, and if you counted all of those, there are 26 out of 52 cards. The probability of B is drawing a king, and there are 4 kings out of a total of 52 cards. Aha, let's see if there's an overlap. And there is. Again, the probability of A and B in this case is drawing a king that is red, right? So we have 1, 2 of those that again were counted when we did the probability of A and also when we did the probability of B. So that's why we have to subtract because we don't want to count anything twice. So that's going to give us a total of 28 over 52 or 7/13. And those are independent. All right, great. Okay. Now, let's look at a non-mutually exclusive example. Again, straight to the question. What is the probability of rolling an even number or a number less than 5? Let me get out my or formula. All right, so we have 10-sided die. So we have our 10 numbers. Probability of A is rolling an even number. So I have 2, 4, 6, 8, and 10. So that is a total of 5 out of 10 numbers that are even. The probability of B is a number less than 5. So we have 1, 2, 3, and 4 that are less than 5. So we're going to have 4 out of 10. Again, note I said less than 5, not less than or equal to 5. All right, so then we want to subtract the overlap. And again, the overlap is going to be an even number that is less than 5. And so we have 2, and we also have 4. And so we are going to subtract 2 out of 10, and that is going to give us 7/10. All right, now the fun part. I'm going to give you some questions. You're going to pause the video and answer the questions, and then you're going to unpause the video and see if you got the answer right. All right, first question. A spinner is divided into 8 equal sections numbered 1 to 8. What is the probability of landing on an odd number or a number greater than 6? Question 2. Let A and B be events with probability of A is 5/10, probability of B is 2/10, and probability of A and B is 13/100. A and B are disjoint. Compute the probability of A or B. And question 3. If a 6-sided die is rolled, what is the probability of rolling a number that is less than 4 or greater than 4? Now, again, making this video to help you. I already know the answer to these questions, but if you don't pause the video right now to answer the questions, you're just cheating yourself. So pause the video, don't just wait for the answers. You can do it. And the great thing is, if you need an example, all you have to do is rewind a little bit. Don't cheat, people. Do your work. It will help. All right, so hopefully you really did pause the video and you didn't just wait for me to go to the slide. But if you did, no judgment. Okay, I'm gonna kind of judge you. Just a little bit. Just do the work. Put in some effort. You can do this. Okay, enough of that. So, we have a spinner with these 8 sections. And the probability of A is landing on an odd number. And the probability of B is a number greater than 6. And then we're going to subtract the overlap. And we only have one number that is odd and greater than 6. And so the final answer is 5/8. If you got it right, great job. Question 2. Keyword A and B are disjoint. So we only want to add the probability of A to the probability of B. If you got 0.7, great job. And the last question. I'm going to show you a couple of different ways you could have thought about this. So one way, you could have drawn a pretty Venn diagram, right? Where you have the probability of A is a number less than 4, and the probability of B is a number greater than 4. And if you just look inside the circles, we have 5 out of a total of 6 numbers that fit both of those. Or you could have used a formula, which is the probability of A plus the probability of B. There is no subtraction because there is no overlap. Probability of a number less than 4, we have 3 out of 6. Probability of a number greater than 4, we just have 2 out of 6, for a total of 5/6. So either way, you got the same number. I know, it's pretty amazing. So that is the addition rule. I will have a couple of links below or somewhere for you to actually get that nice probability flowchart. And keep in mind, whether you think you can or can't, you're right. You got this. You have a great rest of your day. Bye.